We're gonna say hi to Amy Doe. Everyone say hi to Amy Doe.
Hi, Amy.
Okay. Example 4. Write each trigonometry expression as an algebraic expression in U. So this example class is very similar to last night's homework, 29, 31, 33, 35, except in this one, you have U's instead of a number. Okay? So we're going to start with sine composed with tangent inverse of U. Well, inner component is an inverse, so right away you have restriction. Tangent inverse is restricted, what two quads? 1 and 4. But because U is an unknown variable, you can make it positive, you can think of it as positive, and you can think of it as negative. What would you like to think of it as? Positive. So that means you're going to draw your triangle in quad 1. Because it's always easiest, right? It's the best quadrant. All right, so here's theta. Tangent is opposite over what? Adjacent. So I need to find the hypotenuse using Pythagorean Theorem. So u squared plus 1 squared equals c squared. So c squared, well, can I just take a square root of both sides to find c squared? I mean c. Yeah. So c is square root of u squared plus 1. Is that equivalent to u plus 1? Like this. So is it, let's say, 4 plus 9? Is that the same thing as 2 plus 3?
No.
So, square root of u squared plus 1, is that the same thing as u plus 1? No, because this is a pair, right? They can't, okay, so this is not equivalent, so therefore we can't do the above. Ryan?
Yeah, why can't you assume that the adjacent is 1?
Why can't I assume? Oh, because this is u over 1, dear? Because the ratio. Remember that.
Right, okay.
Yeah. Yeah, good question. Right, then I'm just going to find sine of that same angle. So final answer is what? Sine of that same exact angle is, I'm going to, actually, let me write this right here. The hypotenuse is now what? Square root of u squared plus 1. So sine is just simply opposite, which is u, over square root of u squared plus 1. Rationalize that for me. What would you do to rationalize? Multiply top and bottom by its own denominator. Okay. So final answer is u square root of u squared plus 1 all over u squared plus 1. Question number 2. Can I cancel this guy? What? No, because again, the bottom is what? It's a couple, right? It's like they go together, you know? It's like a set of twins. Okay, that's my final answer. So B, similarly, we're going to start with a triangle. Secant inverse is restricted where and where? 1 and 2. Because u, again, is a variable and that's unknown whether it's positive or negative. Where would you like to draw the triangle? 1, okay. And secant is what over what? Hypotenuse over adjacent, so u over 1. And again, because this is u over 1. Now, in your book, it says use absolute value when needed. This is when you're going to need to use an absolute value. Can you see that u is a hypotenuse? Hypotenuse can never ever be negative. X and y can, depending on the quadrants. But because u in this case represent the length of your hypotenuse, this is when you're going to go ahead and put an absolute value. Then I need to find the opposite. Can I use Pythagorean Theorem again? Heck yeah, okay. Then unknown, which is a squared plus 1 squared is 1 equals u squared. Is that correct so far? Move the 1 over, so a squared equals u squared minus 1. Then a equals square root of u squared minus 1, which someone tell me, is that the same? No? No, it's not, okay? In this case, because it's definitely factorable, but my factors are not identical. Can you see that? So you can't take it out of the radical, okay? So leave it as that. So this one becomes square root of u squared minus 1. Then I have everything I need. So cosine of that same angle is just what? 1 over absolute value of? You, what? You did all that work for nothing? Yes, you did. Okay. Now, I mean, on a test, couldn't I easily change the cosine and outside to sine or tangent or anything of that nature? Yeah. So we went through the motion so we know how. Okay, that's the end of, yes, Trey.
So will we get marked down if we don't put absolute value bars for hypotenuse?
Would you get marked down? Yes, because you need to understand that all hypotenuse is a positive distance. Okay?
But if it's always a positive distance, then what's the point of putting absolute value?
Because u is unknown. U can be positive or negative. So to ensure that the hypotenuse is always positive, we have to use the absolute value.
Right.
Is that because we don't know if the denominator is negative? And
Well, the denominator is always 1, because this is just u over 1. So the denominator is always positive. Okay. Now over here, can you see over here where I put u on the opposite leg? I didn't need an absolute value. Okay, because in the unit circle, the y value and x value can be negative. If I were to draw this right here in quad 4, then that's definitely negative, right? But we picked quad 1 for the sake of these things.
So how come you don't put absolute value on the square root or the u squared plus 1?
Where? Oh, because radical can be negative ever.
Oh, yeah.
Yep, good question. Can you guys see how she said I don't need an absolute value here? Because radical can never ever be negative anyway. Right? Anything else?
So, for example, if it was a different variable like x or h, you
Doesn't
would
matter.
still put an
Yeah,
absolute value.
it's just any variable you
Okay.
use. Yeah. For the hypotenuse.
Yes.
Okay, let's go to 3. Example 7.3 I meant. This is the whole section is solving. How good are we at factoring? Good? Awesome, right? Example 1 says solve on this interval. Okay. That means theta can it be negative? No, because it says the smallest answer you can have is 0. The largest you can have is near 2 pi, but not at 2 pi or over 2 pi. Yes or no?
yes.
Yes. All right, let's solve. What do you want to do first? Add 1, okay. So 2 cosine. By the way, divide by 2 is fine too. Don't be scared of dividing first. Okay. Now divide by 2. So cosine of 2 theta is positive half. Can you guys see that this is a regular cosine function, not an inverse?
Yeah.
That means there's no restriction, by the way. I can be in any quads, okay? So cosine of some angle is a positive pi, positive 1/2 I meant. What quadrant or quadrants will this come from? 1 and 4, okay? So cosine of something is equal to 1 over 2 or half. What angle is that in the unit circle? Pi over what? 3. That means in quad 4, what angle is that? You can't use negative, because look at the restriction.
Oh, pi minus
5 pi over 3. Okay. So we have 2 locations will give me cosine of 2 theta equals a half. So what you need to do then, you break this up. You go 2 theta has to be equal to pi over 3. Or 2 theta has to equal to 5 pi over 3. Do we box that up? Call it a day? No, because you're solving for 1 theta, which is like 1x. So divide both sides or multiply both sides by what? Well, yep. Divide by 2, which I like to multiply by half. Okay. Divide by 2, multiply by half. So theta over here gives me a pi over 6. Theta over here gives me a 5 pi over 6. Do you think that's the end? No. Someone tell me why no. I got theta equals pi over 6, theta of 5 pi over 6. Is that the end? Do you think this number right here does anything? Someone tell me, what's the period of a cosine parent? 2 pi. What is the period for this function? 1 pi. But aren't you solving from 0 to 2 pi? So from 0 to 2 pi, how many periods can you graph? 2 full ones. I'm going to hold on to that thought. If you're graphing 2 full ones, shouldn't you have 4 different answers? Because it repeated the second time as well? Okay, so let me just kind of sketch it out. You don't have to do this. Okay, so here's one parent, right? Oops. Would you agree that's one parent, one period? And that's normally 2 pi. Does that make sense so far? But if you are starting, if from 0 to 2 pi, it's, well, cosine starts it. Sorry, I need to make sure I'm looping a full period. Right? That's one full one. Is that okay? And then like, okay. So can you see that I should have how many different answers? 1, 2, 3, and 4. Okay. So with that said, we need to find the period. Okay. So this period right here, what's the formula for a period of cosine? 2 pi divided by b value. And what's the number in front of theta? 2. So what's the period here? Pi. Now this is super important because that's what I need to add to have repeating answers. Okay. Your denominator is 6. So pi in essence is 6 pi over 6. So what happens when I add 6 pi over 6 to pi over 6, which I have down here already? 7 pi over 6. And then I'm going to go over here and add 6 pi over 6, which is 11 pi over 6. Can I add another period? No, because then I will be going over 12 pi over 6. So write that right there from smallest to biggest. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay? So that right there is the answer from 0 to 2 pi. We're going to go and find the answer to B. We're going to start with the period. What's the formula for the period for tangent? Pi over b. What's b value here? 3, right? Because the number in front of theta. So that's going to be 3. So your period's pi over 3. Is that going to be useful in a little bit? Yeah? Okay, tell me what you want to do first to solve for theta on here. Subtract the 1. So now you have radical 3 times tangent of 3 theta equals to -1. What's your next move? Divide both sides by rad 3. Then tangent of 3 theta equals -1 over rad 3. This is not an inverse, so there's no restriction. Tangent of something is a negative answer. What 2 quadrants is that going to be in? 2 and 4. Okay. What angle in 2 will give me a -1 over rad 3 ratio for tangent? Multiple of 30 degrees, but I can't have 30 degrees. I'm in quad 2, and I can't have degrees. I don't want radians. So what would that be? 5 pi over 6. Okay. Then in quad 4, that will give me what? 11 pi over 6. So over here, I'm going to take 3 theta equals 5 pi over 6, or 3 theta equals 11 pi over 6. Okay. I'm going to multiply both sides by 1/3. Then single theta is now 5 pi over what? 18. Then single theta is over here 11 pi over 18. Is that all? Can we box that up? No. Earlier we stated the period, which is a pi over 3. Let's make it into common denominator of 18. Why, by the way? Why would that be useful for us? Because I'm just going to add, right? So if pi over 3, denominator 18, what's the numerator? 6 pi. So here we go. We're going to start with this guy over here, okay? 5 pi over 18 plus 6 pi over 18. What? But isn't that the same thing as this guy over here? Why? So now here's the question. Do I have to use both angles? No. And why is that for tangent? How come tangent I don't need to use both of my angles to get all solution set? Because they're just what? They are just opposite of the other one, okay? In cosine, in sine, can you see that the two angles are not directly opposite of the other? Okay, so that's why you will have to use both. But in tangent and cotangent, they're always like that, so you don't have to. Can you see that if you use the right side, 11 pi over 6, and you subtract your period, you will also get all of the small ones as well, okay? So make sure you can use one for tangent and cotangent. You can add or subtract, okay? So don't forget to subtract sometimes. So I'm just going to use one side here, which is the left side, and keep on adding. Chanel? You're right. That's absolutely right. Okay. All right, so let's add another. So 17 pi over 18. Keep on going until how far, by the way?
2 pi.
Okay, 2 pi. All right, so add 6 more, which is now what? 23 pi over 18. Add 6 more. 29 pi over 18. Add 6 more. 35 over 18. Can I add more? Is that it? That's it. Okay, that is it. And again, you can use 11 pi over 18 on the right side and subtract to get the small one, and then add to get the rest. Questions so far? All right, let's go to cosine of this one. What's the period here? What's this period? Just 2 pi, right? Because what number is in front of that theta? A 1. So I don't have any horizontal compression or stretch to the period, just 2 pi. If the period is already 2 pi, do you need to add or subtract anything? No, because that's the most you can go. So solve it normally, okay? How do you solve this? Okay, you're right, compose. Or you can just see. Cosine of something, it's what? 1. So what is that something? 0 radian. Isn't that correct, guys? 0 pi, which is 0 really, because I'm not using a bubble, right? So would you agree I can just take this guy and set it equal to what? 0 pi, which is 0. How do you solve for theta? You add a pi over 4 to the right. So theta just simply pi over 4. Now, if you just quickly check, would that be true? Plug in pi over 4 for theta. Pi over 4 minus pi over 4 is 0. Cosine of 0 is 1. Yes, Chanel?
Why do you say equal to 0 and where does that 1 go?
Because cosine of what, Chanel? What angle equals to 1? So this right here is, this is really the question. If you were to compose both sides, right, Chanel, by an inverse, would you agree that this is a true statement? Yes. So cosine inverse of 1 is what? No, not cosine. Tangent would. Yeah. Right. So that's why some of us know it's straight up, and then we just put 0 right here. Did I answer that, Chanel? Yeah. D for dog. What's the period? 2 pi, because what is the number in front of theta? 1. So I don't have to add or subtract. Whatever you find is what you find. Okay. What's your next move? Factor. Oh, I love you guys. Okay. How do you factor that? Some of you do better if you use x, so let x be cosine of theta, okay? And that's okay, you go like this, 2x squared minus x minus 1 equals 0. Work with that, and then some of you can just factor straight up. Okay, take a second to factor that for me. Once you have your factors, can you compare before you go on? Because if your factors are wrong, then the whole thing's wrong. All right, my awesome Lucian, what are your factors? And by the way, Lucian, do you use x or the cosine? Both?
I can just replace that.
That's okay, give me the x, or whatever.
2x plus 1,
2x plus 1.
and then the other one is x plus.
Do you guys agree with that, by the way? Yeah, and then every time you see an x, you can just put back to what? You mean cosine? Okay. Cosine, okay. So if you're comfortable with x, do that. Okay, then just replace it again. Anthony?
Why'd you make it?
I meant 0. Lucian probably said 0, and whoa, did I just erase the whole thing? Oh, there it is, okay. All right. I meant to say 0. Thanks, Anthony. Okay. Now that we have the factors, where do you go? Solve by how? Set each factor equals to 0. Then I'm going to go to cosine of theta equals negative 1. That means cosine of theta equals a negative 1/2. Is that correct so far? On this side, straight up, cosine of theta equals 1. Okay. Now, cosine of an angle equals 1. What angle is this side talking about? Back to 0, huh? So 0 or 0 pi. Okay. Over here, how many quads? 2. What quads? Quad 2 and 3. Because it's negative cos, so 2 and 3. So determine the quads and then determine the angle. What angle in 2? 2 pi over 3? I'm going to hold on tight. Cosine of 2 pi over 3 is a negative 1/2. Agree? Disagree? We're still thinking? Agree. Don't you have your plate still? Bust it out. Confirm. Hey. Did you guys agree with that? That means in quad 4, it's still multiples of pi over 3, but I can't write pi over 3. I have to write 4 pi over 3. Now, because the period is 2 pi, I don't have to add or subtract anything. I'm just going to straight up write the answer from smallest to biggest. Okay, let's move down. Egg and fish. There you go. E and F. Okay. Which one do you want to do on your own? E. Okay, you try E. Is it too early for red wine?
No. Never too early, right?
That's only 10.
So Who wants red minus? Oh, it's the 1 minus x per theta equals yeah.
Oh, you got it. What are those called?
So choose a 5.
Oh, so negative 10 is 1. That would be 1 minus x per theta. 1 minus 2 x per theta. Take a look.
Then what is the problem? I would have sine squared.
Oh, no, it's 1 minus x per theta.
So cosine squared theta equals 1 minus
I'll be fair, anybody need to refresh your own. So you just cancel out. So it's negative 10 squared. Doesn't cancel. Oh, wait, no.
It has to be,
1
it has to be squared.
minus 2. But also.
So what I did is I
And then just add that?
into 1 minus x.
Yeah, but what am I gonna do?
And then I turn this
You do factors. If you move this up, then it factors.
There are multiple ways to solve this, so.
But that's that can
Bring over the negative or the 1.
Okay. Marco, how would you like to execute this?
Subtract cosine 2 theta.
From both sides?
Yeah.
Okay. Do you guys agree so far? Subtract cosine square of theta. That means I got sine square of theta minus cosine square of theta minus sine of theta equals 0. Okay. Now what? Trig it in. What are you thinking about?
1 minus sine squared.
Okay. Cosine square of theta plus sine square of theta is always what? 1. You got to use that. Because when you have one equation, you can only have one variable for the most part. Okay. So can I take out the cosine? Because most of it's already in sine, right? So you want the least amount of work as possible. So sine squared minus something, minus sine of theta equals 0. What is that parentheses now?
1 minus.
1 minus.
1 minus sine squared of theta. Okay, I'm just gonna pretend he's not there for now. Okay, minus 1 plus sine square of theta minus sine of theta equals 0. Should I combine like terms? Can I combine like terms? Yeah, how many sine squared would you get? 2, right? Should I write in order as well, power?
Yes.
Yes. Why? What's the purpose when you write in order? I can do what now?
Factor.
Yeah, so go ahead and factor it out. Isn't that very similar to the one we just got done by factoring? Yep. Okay, factor it out, but now you just have sine as a variable.
Sine theta, we multiply out plus sine theta, which will give you minus sine theta. But then so you have to cancel the positive term. You put the negative over here, so it's positive sine theta minus 1 minus sine theta. So you equals that.
You done with the egg problem?
No. We have a second problem.
Supposed to be as lazy as
But most of you are down to the factoring piece. All right, my awesome Sophia, what are your two factors?
2x plus 1.
Whoa, it went to sleep on me. Chanel, can you wake her up?
Wake her.
There you go. Okay, Sophia?
2x plus 1, x plus
2x plus 1 times?
x minus 1.
So x minus 1. So Sophia uses x. That's perfectly fine. Every time I see an x, can I just now plug in a sign? Yeah. Take each factor, set it equal to 0. So sine of theta is now straight up negative half. And then sine of theta is now positive 1. Okay, so where's sine at positive 1 at? Pi over dos. Over here, let's decide on the quadrants before we focus on the angle. 3 and 4. Okay, so in quad 3, Trey, what angle is that in quad 3?
And quad 3 for negative 7.
Yes. Yes. Okay. Uh-huh.
So for these, do we have to keep on adding them?
Good question. Do we have to add at all? Or subtract anything? Because a period is what? It's 2 pi already. I'm already maxed out. Okay. David D. What angle in quad 4? Perfect. Okay, let's write it all together. Smallest to biggest. Pi over 2, 7 pi over 6, 11 pi over 6. We have one more in this alphabet soup question. I threw some eggs in my soup. I got some. Yeah. Okay, here we are. How would you attack this? There are so many ways.
Trig identity.
Trig identity again?
Yeah.
Okay, what do you want to substitute?
Cosine.
Okay, take out cosine. Okay, so 3 sine square of theta equals, Amanda, cosine square is what, dear? What do you want to take out cosine square to substitute with what?
1 minus sine square.
Thank you, Amanda. Okay. Katie, what do you want to do next?
Okay then.
Add sine squared theta to both sides.
Very good. So 4 sine square of theta equals 1. Okay. Where's my Amy Doe at? Her card was up. Okay. Anthony, what's your next move? Divide by 4. So sine square is now a quarter. Okay. What do you want to do next? Square root. Okay, think about the square root. Oops, I forgot theta. Anytime you take a square root, oh yeah, sine of theta equals plus or minus. Plus or minus what, y'all? 1/2. So it's gonna come from all quadrants. So theta is, give it to me from smallest to biggest. Pi over 6, comma. 5 pi over 6, comma. And last angle? You're right. So write yourself a note. Dear self, when I take a square root, I need to be mindful of plus and minus. Yes, for now.
For the last one, can you go over again why there's no, why you don't add the period that you did for the other?
Because what's the number in front of theta?
1.
1. So
Oh, okay.
2 pi divided by 1, which is maintaining at 2 pi. All right. Bust out your calculator. I want you to use your calculator to solve A. Round to 2 decimal places. If you dare. I want you to try using the calculator to solve A, and then I'll teach you how to use the calculator. Ladies, focus, solve A. Once you have an answer, compare your team. By the way, according to the instruction, what mode should you be in? Gradient, because it's limited from 0 to 2 pi. Anytime you see 0 to 2 pi without any bubbles in it, you are in the gradient.
Actually, you guys take one.
Oh, wait, I was,
No gradient, but you said cosine. Oh, you're right.
So Amy Z, can you read me what A says?
Cosine theta equals 0.2.
Yeah, cosine of theta equals 0.2. Then you're supposed to solve for theta, right? What did the calculator say?
1.37.
Okay, so theta is 1.37 radians. Is that okay? But isn't that just a normal cosine? So technically I should have an answer in quad 1, and shouldn't I also have an answer in quad 4? Yes or no? Then how come your calculator give you both? Okay, so here is, would you agree that you borrow a cosine inverse to solve? You borrow a cosine inverse to solve. Because the original question is a regular cosine, is that true?
Yeah.
So to solve for it, you compose both sides by cosine inverse, which means you're borrowing it to solve for this piece. But anytime that you tell the calculator to use an inverse function, is it restricted? Yeah, so it will only give you what? One answer. But you have to analyze the question to say that there are how many? There should be 2. Then how would I get the answer in quad 4? 2 pi minus that radians. So what's 2 pi minus that radians? Which is what? 4.91. Okay. Then I'm going to show you how to get all of the answers a different way. Write that down, and then here's what I want you to do. We're still on A, right? Can you find the buttons at y equals? We're going to break this one equation into 2 equations. Can you see the right side? What's the right side say? The right side of this equation, what does it say? The right side of this equation. 0.2, 0.2. Can we all agree? You can pick. Either enter that in y1 or y2. It doesn't matter. So go to y equals. Enter that in y1 or y2. You pick. Whatever you already entered in, the other y, put in the left side. What's the left side of this equation? Cosine of theta. I believe you have to use x. So go ahead and cosine of x. Can you make sure all of you guys have the same inputs? Y1 and Y2, you can switch them. That's not important. At any point, do I want inverse at all? No, just enter in the right side and the left side. Right? Are we good? Are we all on the same page? Yeah. Yes. Can you see the restriction? What is this problem restricted to? 0 to? Guess what you do with that? Go to your window. Go to window. X0 should have what? 0. I meant X min. X max should have what?
2 pi.
Then after you enter in X min and X max, I want you to zoom and zoom what? Great. Good job, Janelle. Go there. Can you see that there are 2 curves on your calculator?
No.
Yes.
If you said no, make sure you wait before it's loading.
Oh.
By the way, a line is also a curve. It just happens to be a very straight curve. How do you find the answer to those 2 curves? Second choice is go down to what? Intercept. Go do it for me to see if one of the answers matches.
So is the blue line like the restriction?
The blue line is your second piece, my dear. There's 2 curves. 1 curve, 2 curves.
Yeah. Oh, second curve.
Mine's kind of weird.
That's okay. It doesn't. By the way, it doesn't matter. First line, second line. Okay. If you hit enter, it will immediately go to the other one that's not on. Okay. Trace it. Does it match? Yes. All right. Now you're on your own for B. You and your team work out B together.
Try turning it off.
You put in 4 and
Oh, that's what I'm trying to figure out. I can look for it. All right, you and your team work out B all by yourself. Don't forget to hit zoom fit, y'all.
every single time.
Every new equation you have. Where did you guys put 4? Why 1 or why 2?
I don't even know.
Why 1?
Okay. But by the way, it doesn't matter.
No.
Whatever you don't put on Y1, put on Y2. What do you put on Y2?
3 cosine.
Whatever's, if you have an answer. Your X window should be the same, right? But make sure you zoom fit, because you have a new equation. Once you have your answer, compare them with your team. How many answers does the calculator show? 1, okay. Trace without 1. If you have a new calculator, it takes a long time to load. You guys all have the same answer on B? Yes. Awesome. You know, okay? On the top? All right, now that you guys are experts with the calculator, Lauren, honey, what did you get for B? 4.53. Aiden, do you agree? Yep. Can we all use a calculator?
Yes.
Okay, let's do the last one. Can you help me read the instructions, please? Alexandra.
So each give a general formula for all the solutions, list 6 solutions.
Awesome. Can you see that here? You have to list a formula because did I give you a restriction for your theta? No. If the restriction for theta isn't there, and this is very common on an exam or worksheet, then that means it will have infinitely many, because isn't a trig function repeating and repeating forever? So when that's the case, then you have to give me a formula, right? Then it says here, give me the first 6. All right, here we go. Solve it normally. What would you do? Add rad 3 to both sides. So 2 cosine of single theta equals rad 3. Then divide both sides by 2. Cosine of theta equals rad 3 over 2. What 2 quadrants is it going to come from? 1 and 4. Did we decide on the radians of 1? Pi over 6 and 11 pi over 6. Okay. Now we are also going to decide the period because I need to add multiple periods of that. What's the period here? 2 pi. All right. How many equations were we going to have? Just 2, right? So theta is, the first angle is pi over 6 plus 2 pi k, because I need multiples of that. Then the second equation is, what else? 11 pi over 6 plus 2 pi k. Let's define k really quickly. Where k is, it's in a set of what? All real integers. Okay, so that's our equations. There's 2 of them. Then it says, give me 6 of them. So I'll take negatives, I'll take positive, I'll take whatever. But usually we want to start when k is 0. When k is 0, What's my smallest theta? Pi over 6 and 11 pi over 6. Okay. Then k is 1. That means I'm adding the next period. If I'm adding the next period, and the period is 2 pi, with denominator of 6, can I just make it 12 over 6 pi? Yeah, so let's just add 12 over 6 pi until we get all 6 answers. Okay. So, comma, give me 2 more. 13 pi over 6, comma, 23 pi over 6, that's 4. 2 more. 25 pi over 6, and is that okay? 37? 35? Okay. Remember we're adding 12, so that's 35. Okay. Can I box that up? All right, let's do B. B says solve for theta. Sine of 2 theta equals 1. So straight up, where would you have that angle at? Where is sine equal to 1? Pi over 2. So pi over 2. Bless you. So 2 theta equals pi over 2. True or false? That means 1 theta is pi over 4. I need an equation. So do I need to find the period? I'm sorry, Chanel, go for it.
Is this for A or for B?
This is not for B.
Okay.
Yeah. What's the period and how do I find it? Period is always 2 pi divided by B. What's the B value in this question? 2. So the period is pi. So for me to get all of my answer, I can just keep adding the period, right? So theta is pi over 4 plus what? Pi k, where k is belong in a set of all integers. So that's that. Give me first 6. When k is 0, theta is just pi over 4. If you're adding a pi every time, can I think of it as just 4 pi over 4? Okay, so what's your next one? Next. Sure, next. Sure, next. 17, and 21. So there you go. Do you guys remember this last year? Because I remember teaching this in Algebra 2, right? Vaguely.
No, stop right there.
Okay. All right, last one. So as you can see, I'm giving you 2 different trig functions here to see what the difference is, okay? So tangent of theta divided by 2 is 1. So straight up, what 2 quadrants? 1 and what? 3. 1 and 3. What 2 angles? Pi over 4 is in quad 1. What else? 5 pi over 4. Okay. So now, but here's the thing about tangent. Can you see that in tangent, the distance from one angle to the next is identical? So in tangent, because the distance is identical, by the way, that's what the period is just pi normally, because you only need to go half a circle, right, to get back to yourself. In tangent, I would not need to use both angles, okay? Because, again, because the distance is equal. And in any of these, if you see that the angles are equal distance, you don't need to use multiple equations. And here's why. Can you see the very first one, cosine? The 2 angles are not equal distance. That's why you have to use both to get back to one another. But here, I can just use 1, and I can go multiples of it. Okay, so which one do you want to use, pi over 4 or 5 pi over 4? Okay. So theta divided by 2 equals pi over 4. Then I need to get rid of the 2. Can I multiply both sides by 2? Okay. Then I have theta is now a pi over 2. Then I need to find the period. Period is, period formula. You're right, but what's the formula? Some of us don't know that. Pi over b, yeah. So the reason you got 2 pi is because your b value in this one is what? Aha, I like that. So that's why it's 2 pi. So your equation is pi over 2 plus 2 pi k, where k is all real integers. Okay, then I'm just going to list the first 6. So when k is 0, I have pi over 2. When k is 1, 2 pi with a denominator of 2, can I think of it as 4 over 2 pi? So add it. So that's 5 pi over 2. Next. Next. Keep on going. And last. 21 pi over 2? Can I subtract sometimes if I really feel like it? Yep, you do what you want to do. Whatever floats your boat's right. All right, that is an egg roll for today.